Every moment tonight, they led me to you. Every single time you look at me, I lose it too. Why don't you come sit next to me? Let things happen naturally, like it used to be. I don't wanna go and waste another day, mess it up again, lost in my way. I'll be the one to have the highest price to pay. If I make it home tonight, may I hold you one last time? Let me hold you one last time. What if it's too late for me now? What if you've gone to someone else, so we can never be the same? How can I make up for my sins? Now I'm lonely and it kills me. Can you hear me, babe? I'm lonely. I know you don't wanna talk, but just pick up the phone. We could go for a walk, talk about the things we know. Why don't you come sit next to me? Let things happen naturally, like it used to be. I don't wanna go and waste another day, mess it up again, lost in my way. I'll be the one to have the highest price to pay. If I make it home tonight, may I hold you one last time? Let me hold you one last time. What if it's too late for me now? What if you've gone to someone else, so we can never be the same? How can I make up for my sins? Now I'm lonely and it kills me. May I hold you one last time? Let me hold you one last time. What if it's too late for me now? What if you've gone to someone else, so we can never be the same? How can I make up for my sins? Now I'm lonely and it kills me. Can you hear me, babe? I'm lonely. Hey now, could we stop the world tonight? Just wanna lay down and feel your body close to mine. All I wanna hear you say is that we're never gonna leave this place. But if we ever fade away, I hope you know I'm feeling so high when we're together. Yeah, let's make it last forever. We'll stay young, stay young. We are the perfect lovers, don't care about the others. I wanna stay young, stay young with you. I wanna stay I wanna stay Hey now, we are young and wild and free. I just wanna shake hands. All the love inside of me, underneath the golden sky. We sit and watch the evening tide. I see the fire in your eyes, and I gotta say, I'm feeling so high when we're together. Yeah, let's make it last forever. We'll stay young, stay young. We are the perfect lovers, don't care about the others. I wanna stay young, stay young with you. I wanna stay young. don't care what people say, people say, people say. I'm going crazy for you, baby. Don't know how you're making me feel this way. What can I say? That's what I like about you. So dangerous. I get this rush when I'm with you. I go all in to lose or win. Real things up to knock 'em down. It's the way we keep our high moving like a hurricane. There will come a time for when we can wash away our sins, settle down, but until then, we're like a hurricane. I've been waiting for somebody just like you, hoping, praying, run away to something new. My mistakes brought me to this place. I had to fall to get to you.
Hello, 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 hello. Everyone. How's it going? How's it going? Welcome back to yet another live stream. Welcome back to yet another live stream. Today was a hectic day. I had to travel a little bit for some work. Then there was office, and for the entire evening, every day I think I'll start streaming at 6, then I'll stop by 8, 9 o'clock. But then I slept. The usual thing that I do. So yeah, it's a bit late. So I was thinking of what to do today. I was thinking of whether to continue with the fast API exploration, whether to do this, whether to do that, and I also had to create thumbnails. So I just became lazy and I thought, okay, I'm anyways gonna do some studying, so I wanna do some algo expert, I suppose, or need code something, and let's just stream. So that is what the entire plan is. Sorry. So that's what the entire plan is today. And let's see how the setup goes. It's a new setup. I like it till now. I have my main monitor, which I got new, which is a 2K monitor. And since the resolution is so high, the things got messed up quite a bit here and there. So that's one thing I still have to figure out. And on the right hand side is my old monitor, which is helping me at least monitor my chat, which I used to do from my phone. But now I can do it from here. That's one. Okay, right. I hope my audio and everything is correct. There's no issues there. There's no issues there. And yeah, how is everybody's Tuesday going? How's everybody's Tuesday going? So if you keep seeing me looking on the right hand side, it's not because I'm looking at something. I'm looking at my right hand monitor. Yeah, it's all professional setup. I've got a monitor arm. I've got 2 monitors. I've got lights. I've got shit going. So yeah, professional streamer. I'm a professional streamer. So subscribe because people need to understand that I'm a professional streamer. It just cannot be my setup is professional. My numbers should also be professional, right? Million views. So we'll just wait for some time and see if anybody joins, and then we'll get started. Today I am planning to work with Algo Expert. So, how is everybody doing? The stream is going good. No frames drop yet. My voice looks okay. Uh, I'm not gonna listen to my voice today and see how it feels, but I feel that it's gonna be okay. But maybe I should want. I'm gonna listen to my voice today and see how it feels, but I feel that it's gonna be okay. Maybe, okay, that sounds pretty good. Oh man, I have to log into every other place now. Ah. So my Chrome is not working and I'm locked out of GitHub. Hmm. That is kind of sus. So let me just try to log into GitHub first. So let me just log into GitHub first and then we'll see. Are you a real person? Use the arrows to rotate the asset to face in the same direction as the asset in the left image. Okay. Again? What? I'm not a robot, trust me. Okay, I quickly gotta log into GitHub. It's gonna take a little while. I'm sorry, but just yeah. Till then, we can just normally talk like humans. So, how's it going? Everybody? How is your Tuesday going? Are you prepared for almost, like not almost, for the middle of the week? Are you prepared? Are you prepared for that chat? It's not indicator. Oh, okay. Okay. Trust me, chat. I know how to log in. It's just taking a little while because I forgot my password. So. Will it give me an authenticator thingy? Okay. Okay. Okay, we are back. Seems we are back. And let's now log in to Algo Expert. So we have to log into every other platform now. My Chrome has stopped working because I haven't updated it for quite a while. But let's see how we're going to do that. So now we're just going to ignore it. Chat. Oh man, I have to import everything. Hi, couldn't join class to got a little bit fever. Hey, no issues, you should take rest. How are you doing now? I hope you're doing good now. Going to log in here? No, right. Maybe I can sign up, but is it necessary? Let's do it. So how are you feeling today? How are you feeling today? I hope you're good. You had good rest and had good, like you had medicines.
Every moment tonight, they let me
Oh, wait. If I log in, you're asking me to pay. What the fuck is wrong with you, dude? Why will I pay you if I...
next to me, let things
Okay,
happen
we don't have to log in, I suppose.
like we
Oh,
used
oh, okay, okay. Good. Should take care of your health. Should take care of your health. If you need some rest, go rest. But thanks, appreciate you still sticking around. But you don't have to stick around. Feel free to go ahead and take rest. The weather is a little bit off, at least in Bangalore. I don't know. I think you're in Kolkata, right? So, how's the weather in Kolkata? Here, it's a bit gloomy for the past 3 4 days. It rained on Sunday, I think, or Saturday, and yeah, since then it's been a lot gloomy. So that's that. Is my voice clear or is it mangling? I don't know. Just let me know on the chat if my voice is not clear, and we'll see what we can do about it. On my monitor, I can see it's looking good. I was solving first missing positive in most optimized way. Most optimized way. Nice, nice, nice. Uh, yeah. So since we have things ready, I think we should start the live section. Look at that. Look at that. We are live. We are live. So, yeah. Okay. Whether one thing I want to say is if you want to look at hyper optimizations of how people do stuff, one of the things you have to look at is 1BRC. So 1BRC is can you see my screen, by the way? Like, is it too small? Is it too big? Because I'm streaming with 2K and I'm having a 2K monitor now. So I'm guessing the resolution is not upscaling, and like I don't have to resize anything a lot, at least. What you're saying. Oh, okay, I can just copy that anyways. But I hope you can see my screen. But just let me know. I'll just quickly, resize and stuff. At least when I'm seeing my screen, it feels good. It feels okay. So you can look at 1BRC, the 1 billion row challenge. This is a good challenge where, um, so the entire idea of this is that you have a billion rows, and how fast can you parse billion rows and how fast can you process those billion rows. I have not tried it till date because I had a 16, looks good in laptop. Awesome, awesome, okay. So I had a 16 GB laptop in which the 1 billion row file itself is 13 GB, though there has to be a mention of RAM. So it doesn't say here, but it's a RAM mount. RAM mount is a specific kind of a file. So the RAM itself can act as a drive on which the file is mapped. Let's think in that way. I think I may be completely, like I may not be completely correct, but that's how I understand, but I'm not very sure. But anyways, I think people were reading off files and all that. So, so it's a crazy thing. Do I have GitHub? Yeah. So this was primarily for Java, but people then it took off so well that people then started doing it in different languages. And look at that chat. Java being the lowly-poly language it is, Java being the lowly-poly language that it is, it actually the highest thing. So this is GraalVM, but GraalVM is not was not allowed in the very first thing. I think this came back 2 years back. So yeah, so 3 milliseconds, 300 milliseconds. No, oh, this is second, my bad. So 1.5 seconds, 1.5 seconds, 1.6 seconds. Yeah, so like crazy, crazy, crazy optimizations. And people even went ahead and started, like you can see here, 300 milliseconds in Java. 300 milliseconds in Java, right? So the reason behind that is that is you increase the number of cores and all that. So instead of 32 cores, which is according to the problem statement, there are a couple of rules that you cannot use Java standard library. You only can use Java standard library and things like that. No GraalVM binary, things like that. Um, but just yeah. So if you look at the implementations, I'm pretty sure that has to be unsafe and all that. Yeah. So there's no apparently unsafe here. I'm not sure. Why does this thing not show me? Oh, okay. it shows me behind below. Okay, yeah. So like I said, there's unsafe and things like that, which means you directly work with a memory in Java, which is not allowed, but you can do that. So you have bit operations, you have a lot of things, right? So I've already given given it in the chat. Take a look. The reason why I'm talking, and I want to try this someday. Right? But yeah, not right now because it's already been 2 years. There's a lot of videos out there. You can see how people have done it. There are tech talks out there. This became really, really famous, and this is by Gunnar Morling. So this is a really, really good thing. And I think now 1 trillion row count came in. 1 trillion row count came in. Apparently, I don't know. Okay, so someone did this. But yeah, 1 billion row count I couldn't work because I didn't have enough CPU. I didn't have enough memory. I had a 16 GB. So now I upgraded to PC this year, and I plan to do this. And now people have come up with 1 trillion. So the file itself is 13 GB, right? So if I take everything into memory, my idea and things like that, everything just stops working. But anyways, now I have 64 GB PC, so it should work fine. The reason why I'm saying this is for hyper optimizations. Like, I don't know if you're doing hyper optimizations, but you sound like you are because you're talking about in the most optimized way. So I would consider some hyper optimizations. So let's look at YouTube. And I think last year I was already talking about him. His name is John. I'm sorry, John, if I'm pronouncing your name wrong. John Genset. So he did this in Rust. It's a 10-hour long live stream that he did, and he uploaded the video. And yeah, this is really, really good. And I think I'm around I'm around like almost 4 hours of watching this since yesterday. Super nice. He's doing it in Rust, by the way, but again, language doesn't matter. The language should matter of what you can achieve. The language would matter what is there in the standard library, but in general, programming shouldn't matter. So since he's working not with the VM but with direct native code, he is looking at assemblies and things like that and optimizing it. So it's a really good thing. So I want to do a complete research of how people have done their optimizations, and then come up with I love doing optimizations. That's why I started with CPP. Wanted to go into quant. Okay. So quant trading, I suppose you're talking about. That's pretty good. By the way, a lot of quant trading platforms and trading platforms use Java. We think of Java not being performant, but they do. I don't know how they make it performant somehow. I have some tips. Tips are from Jenkov. His name is, what is his full name? Jacob Jenkov. So you can follow this guy too. But yeah, it's like, follow everyone. They're pretty good software engineers who has a lot of different tricks up their sleeves, so you can learn a lot. Gunnar is, again, I think, if I'm not wrong, does he have a LinkedIn here? Yeah, I suppose it's LinkedIn. I really like this theme. But yeah. So Gunnar is okay. Thank God my messages are not open. I was logged in. So he's also a Java champion. Yeah, he's also a Java champion. Awesome, man. These guys, I feel, are awesome. He's currently working with Confluent on the Kafka side. I'm not quite sure what he's working on, but yeah. Anyways, we digressed a lot talking into these things. Let's start getting into programming mode. And I also have Algo Expert, which I'm going to start solving now. Yeah. If I remove the dark mode, yeah, it's gonna flashbang you guys. I'm sorry for that. It was just for a second. I'm sorry for that. Okay. Again, I'm at 100% zoom, 110% zoom, 100% zoom. I hope it's still visible. Again, the reason being it's a 2K monitor, so the resolution is a messed up for me. So everything is a bit small because I used to use small fonts. But I used to increase it while I stream, but I'm not doing it right now because my stream is also 2K. So if you're watching at 2K or at HD, I hope that what I'm typing and like the text is visible. Just let me know if I need to zoom in. Visible. Okay, cool. So here is my IDE. Well, not that, terminal. And let's get started. Okay. Do I have anything? Oh, I have a bunch of things. And I think I was practicing neat code, something like that. Yeah, I don't want to do uh, some things. I don't want to go today because I think morning I was doing some, or yesterday. Yesterday I started streaming. After 15 minutes my internet went down and I just got so pissed off I didn't try to come back again. But yeah, anyways. Okay. Cheers, by the way. Cheers, everyone. And doing this kind of problems are kind of boring, honestly. But yeah, I'm doing it because I want to practice a little bit. It's been a while that I've done algorithm, but it's kind of boring. Who the heck came now? Just give me a second. There's someone at the door right now. Okay, we are back. What are we gonna do? Let's start with binary trees, I suppose. Did we do binary trees? No, but we have a binary tree here. I don't know why. But anyways, so let's create a package. Binary tree. Okay. Why does it not? Okay. Branch sums. This seems like a problem I already solved, but okay. Maybe we can already copy paste this right here because everything would have this, so we have to remove static. Well, we technically don't have to make it public because it's package public, but what am I supposed to do? Supposed to go here. Okay, here's a question. Read a function that takes in, yeah, at least on my screen it's all readable, so 2K is working good, I suppose. Thanks. So write a function that takes in a binary tree and returns a list of its branch sums, ordered from the leftmost sum to the rightmost branch sum. Okay. Yeah. So we have already solved this problem before. 1, 2, 3. So this would be 12 and 15. Okay. So usually you can use a recursion for this, and what happens is that when you go to the, you keep on accumulating the sum, and once you reach the leaf node, you add it, and then you just simply, put it into your buffer, right? So that's basically what we're going to do here. It's basically what we are going to do here. Simple solution and sums. Yeah, it's a little bit less for me also, so I guess this is fine. But there's one thing about a 2K 100 megahertz monitor, 100 hertz monitor, is that, oh my god, the 2K resolution of playing CS is amazing. By the way, I have a Windows dual boot, so I play on Windows. I have a setup there also for streaming, but I don't stream gaming because I'm not good at it. But maybe I can do some story mode someday. But yeah, oh my god, playing CS is fucking amazing, dude. I don't know, Anand, if you're okay. I don't think so. Anand is there. But yeah. Okay. Cool. So, so you can simply say this is private, and this doesn't need to return anything. Think of it like a pointer, and this is the accumulator, right? and we can simply say current sum. Right, we can simply say this is the current sum. So if node.left is equal to null and node.right is equal to null, we can simply say accumulate.listing, but we are leaving out the leaf node, so we can say current sum this thing. Right, so this is what we can do. Right, this is what we can do here. Now, one of the things we have to think about is this node can be null. A node can be null because of two things. When you pass down from here, so we'll do a check right then and there that it's not null. And when you are going left and right, recursing, right, we'll do a check there also. It's very simple, right? So if node.left is not null, you go down left. Look at that, it already knows what to do. Thank you so much. And then here, so node.left can be replaced with node.right, and that is basically it. All right, so we can copy this thing in here, and this here is the accumulator, so this is the root, this is 0. The array list, we could have done it with an initial capacity, but yeah, we don't. So now return accumulator, but here if root is null, depending on what you're expecting, you return back something. So maybe there is a quick test. Okay, so can I just say this is null? Will that just work out of the box? Okay, so you're expecting a, well, I'm pretty sure because the platform didn't. Well, you can always do. I still didn't kind of like what I did, but okay. It's not the code in C that works, it should work. Motherfucker, it didn't work. What did I do? Yeah? Kidding me, right? You're kidding me. Oh my, how did this, wait, how does this, why? Because it's a valid statement. Okay, my bad, sorry. Because it's a valid statement. I didn't even know you can just write like this out of this. And I suppose it's gonna say you don't have to, okay, so that's why it was giving me a warning saying, what the heck you doing, man? Oh, I didn't know that. Look, we learned something today. We can have, so I can have statements. I don't think so we can have expressions. So, can I just have 1 plus 2? I cannot have an expression, but I can have a statement where I can say new hash map. That's all. Well, hash map, and that works. You don't have to assign it to something. Oh, wow, okay. I did not know that. Did you took premium of Algo Expert? Yes, that's why I'm able to look at all the problems. Yes. I did take premium of Algo Expert. It's a good platform for practicing. I had to practice for some things and it feels like a good one. Used to watch him in 2021. I never used to watch him because I used to watch him. I wouldn't say I never used to watch him. Otherwise, how would I know? But yeah, he feels like a more marketing guy than a pure core tech guy. I understand the fact that pure tech guy is like nothing against anyone, but any streamer or any YouTuber that I see is mainly running after making a course about DSA. But I like to see someone code and build something, not someone talk to me that how something works. I don't want to know that. I want to see it being built. That is when I can understand what's happening. So yeah. So again, I forgot the name. Navneet. Navneet from NeetCode is someone I should follow. And now though I have completely like only follow people who do real programming and not just DSA. Okay. The distance between a node in a binary tree and the tree is called its node depth. Write a function that takes in the binary tree and returns the sum of all its node depth. The distance between a node and the tree's root is called its node depth. So you have to return the total depth because the depth of 1 is, so 1 is 0, 2 is 1, 1, 1. There are 4 2s, so 8, 10, 13, 16. Okay. Okay. This is also a very simple recursive problem because for every node, I can return back what is the depth you're at. So since like we start at 0, so as an example, if I say, can I just delete this, guys? I can. Okay. So this is null. This is null. I'm going to remove the dark mode because, yeah, it just messes up the colors and I cannot see shit. So I'm sorry for flashbanging a little bit, okay? So when I switch here, it's going to flashbang. Sorry. Okay, yeah, so what I'm saying here is that you're expecting 0, right? Because it's a single node, so this is what this is what it is. Okay, so it's called node depths. Okay, so this is the problem. What you're expecting when you're null? What you're expecting? You're again expecting 0, I suppose. Of course, it's not 0 because you don't have anything. Yeah. Okay, so if root is null, you can simply return back 0. Otherwise, depth at node. So you can see this. All right. So, if node left is null and node right is null, I suppose what you have to do is return 0. Return 1. No, you have to return 0 because I'm gonna show this right now. Well, we don't call the method, so it's not gonna do shit. Why you're saying +1? Maybe we need to do +1. The AI is telling us what to do. But yeah, so for null it's gonna work, but yeah, so if I bring it back, oh, okay, I cannot do that. My bad. Yeah, so let's do that. Run the code. It's still 0, right? So this is gonna hit. So this is correct, as expected. Now the real question is, when you bring this entire pool of nodes back, how do you do that, right? Okay, how do you do that? Well, one of the things here is that if I take a look at 1, 2, 4, 8, this is at a depth of 0. And how much is the depth at 4? So let's just consider that it's an inverted tree. So the leaf nodes are the root. Let's just think of it, right? It's not a tree, it's a cone. So let's do the diagram. I suppose it's going to be helpful. It's quite interesting. Let's do the diagram. 1, 2, 3, 4, 5, 6, 7. Okay. So it's basically a complete, not a complete tree, what's it called? Whatever it's called. So there is one. Why is there a lag between me and my tablet? Apparently there's a lag. Is there a lag if I do it with my mouse? Oh, if I do it with my mouse also there's a lag. I suppose it's because of this. No, it's not because of that. The problem with Firefox is, okay, this is not working, so I think it's called Mira Whiteboard. Can you just let me use it, please, without logging in? Everybody has AI. Today I was trying to buy a socket, like a socket you usually have. and it's 900 rupees socket. The reason why I need a socket is because my monitor socket is 16 amps and my usual on the walls are 6 amps, so I need a converter. So I'm buying a converter, not a socket. Sorry. So that socket I'm trying to buy, and I thought, okay, Amazon's going to take a day, so let me try Swiggy and Blinkit. So I went on Swiggy, I went on Blinkit, I think, and I searched for it, and it's a 900 rupees socket converter, and it says AI-driven, smart, intelligent. Motherfucker, what smartness are you doing? And it has Wi-Fi built in. Why the fuck do you need smartness? You're supposed to convert 16 amps on this side and a fucking 6 amp on the other side. You need to be smart for that. Okay, something is wrong with, I am supposing with Firefox. Yeah, I'm supposing with Firefox something is wrong. So I'm definitely going to upgrade Chrome sometime very soon. Though I want to use Firefox, but it's supposedly slow. So we're not going to do diagrams today. Sorry. Do I have Figma? I remember, let me quickly stop sharing. Okay, we have Figma. Awesome. It's not really what I want, but it is what we have. Okay, so this is one. Oh. Man, this is a pain in the ass. Okay, I guess this is good. So 1, 2, 3, 4, 5. Just bear with the strokes. Sorry. 6, 7, 8, 9. Okay. Yeah. So now the entire point of this is that this returns back 0. This returns back 0, right? I have not used this, so it's difficult to change colors and all that quickly. Okay. So this returns back 0. This returns back 0, right? So think of it as like an inverted tree, right? It's just a cone. It's just a cone like this. So this guy returns 0. So at the very end, I think we have to do a +1. I think that is why even my I'm not trying to draw busier curves, buddy. Yeah, okay. So anyways, now coming to the main point. So this can return 0, this can return 0. And here, what is the depth? Well, technically speaking, the depth here is 1 plus this and this. So that's kind of sus, right? Because so you return back 0 from here, return back 0 from here. Let's say you just say 1 plus we're just gonna say it's either of the two because it has to be something, right? So let's just say 1 for now, because right here at 2 the heights of the two subtrees are different, so we'll see how it actually works out, right? So this is 1. Now this again returns back 0, and this should return back 1. Sorry. Now this returns back 1, this returns back 0, so this technically has to be 1. Aha. So I suppose you say 1 plus the maximum of these two, or the minimum, because how can you solve it from upside down? So what you have to do is you say 0, then you go up, and for 4 you're saying ki, chalo, you So this is from this side, this is from this side. What if 4 was the root? This would have been 1, this would have been 1. Technically for this particular tree. This is how it would have been. So it would have been total of 2. Total of 2. Now this is a tree. This is at a height of 0. This is at a higher depth of 0. This is at a height of depth of 1. Sorry. This here is a depth of 1. This here is a depth of what is it? This here is a depth of 2, 3. So every time you make a jump, you say plus 1. So what is the depth of this if I start from here? So if I start from here, this was 0, this was 1, then this was 2, then this was 3. If I go the other way around, this was 0, this was 0. I mean, diagram might not make sense to everyone because I'm overwriting, but I hope I'm explaining it clearly, right? So this is 0, this is 0. This here, if I just flip it around, technically it should be 1. So 1 plus some of something. Bye. Take care. Thank you for joining. Thank you for staying around for so long. Thank you so much. And yeah, you take rest. Hope you get well soon. Bye. Okay. So now from this particular guy, I want to go up. And this here should be ideally 2. How do I know it's true? This returns 1. And this also returns. What if these started returning 1? So they returned 1. This returned 1. Okay. So the depth here is 1 plus whatever is the maximum. So it's 2 in here. This would return 2. This would return 1. So 1 plus 1 plus 2. Plus, when it goes up here, another 1 came in from here, but this is 1 plus maximum of either of the 2. So it is 2 and 1, so it has to be 3. Plus, when it comes here again, 1, 1. Then this again is 2. So this returns 2, this returns 3, and it has to be 4. So 7, 8, 11, 12, 13, 14, 15, 16. That is how we are going to do it. Feels like it. Okay. So what we did was from leaf nodes we are returning 1, and for any other place it is very simple as 1 plus maximum of left and right. Oh my god, the whiteboard is really shit for Figma. But yeah, we don't have any other options today. I'm sorry. Okay. So this here is 1. If node dot left is not equal to now you say depth of node as this, left depth is this, so this can be 0. We can simply say like this, right depth. Now here's a little bit of problem. How do I send back the total? You have to rethink. You have to rethink the problem. So this is 1, and you just, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9. If this is considered a tree, it will be 0. If this is considered a tree, it will be 0. If this is considered a tree, it will be 1. Now, if this is considered a tree, this is considered a tree, it again would be 0. And what is the depth of this? What is the depth of this guy? Because I mean, we can easily come down. I don't want to do that. I want to solve it in a recursive return way. That is the problem. I do not want to solve it in a way where I pass down and just add. That's pretty easy, right? That's pretty easy. I don't want to do that. I don't want to do that because let's look at how we would solve it. So we don't return anything. Sorry. Passing like this. So you return. Otherwise, and it should be as simple as that. Right. So depth here. Yeah. So this should be the answer, but I do not want it to be solved in this way, honestly. I don't want to solve it in this way. Solve it in this way is easy. Why is it? Oh, sorry. I'm just counting the number of notes. This thing. So that's not correct. Hold on 1 second. Sorry. Yeah. So you still have to return this, and depth here is 0. So int d is 0. Int left is 0. Right. 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 Depth of 0 is equal to, why is d 0? D is 1. 1 plus left plus right. But when it comes to returning, you say 1 plus max left right. So this should be the answer. My bad. Sorry, I did it wrong. Sorry. How the fuck it's still wrong? What? What did I do wrong in here? I don't need this D for some reason. I could put it. But what's the total depth? That's pretty sus, right? That's pretty sus. Like I said, I'm sweating. Hey, you know what? We can try something different. We can now say this is void. Don't return anything. Okay. But in current depth, and let's call it total depth. Total depth ref, because it's a reference. Technically speaking, right? It's a reference, technically speaking. Let's refresh this, see what's happening. Okay. So in here, Mhm. Right. But what is the total depth here? So we have to calculate here too. Yeah. How about that? And here, total depth ref. So this is 0. Total depth ref. Total total depth ref. Now this should be working. Hopefully I didn't mess up anything anymore. Hopefully. Yeah. But this is what I didn't want to do. I didn't want to um I don't want to return void and do this ref thing. This is a more C-like approach where, like, yeah, it's more a C-like approach. Let's foresee that this actually works fine. This works fine, but this is what I wanted to do. I wanted to return int here. So let's try to do that. Why not? Okay, let's call it 2 for now. And the main thing I do not want is this. So let's call current depth. Okay. Sorry. If this is this, you just return current depth. Okay. So you have to return it. Okay, that's first thing. If this here is this, you make this function call when you have to call 2. Calling 2, and you're going down, passing this thing, and here you would. So we can do something like this thing or 0. So let's just call it left for now. Okay. So right, this also has to be right, has to be right. I suppose what I can do is current depth plus left plus right. So this is the total depth at a particular node if I consider that to be the root. And I think that should be it. So I just will pass this and this thing, and here return this, and let's see if that works. This is what I wanted. This is exactly what I wanted. Awesome. Which means I can now nuke this guy. I do not need it. Yeah, this makes total sense. And this needs to be renamed to. This can be renamed to depth at node. Holy shit, it's an easy problem, but we did sweat a lot. But we did it. So yeah, cool. So another one done. Did you mean to close that tab? If I click on close, what do you think I'm trying to do? Man, it just keeps flashbanging. I just don't know how to solve this problem. That if I open up, if I use Dark Reader, in a second page, it just messes up everything. Okay. Chat, are you okay to get flashbanged, or do you want me to keep using this stupid Dark Reader? Evaluate expression. Okay. So you're given a binary expression tree. Write a function to evaluate these mathematics. there's someone at the door again. Yeah, okay. Okay, we'll take a break. I'll have some tea, but not right now. After we do this problem, we'll take a break and grab some tea. Yeah. Okay, so evaluate expression tree. You're given a binary expression tree. Write a function to evaluate this mathematically and return a single resulting integer. All leaf nodes represent operands, which will always be positive integers. All of the other nodes represent operators. Acha, okay. And they will always be positive things. There are 4 operators reported. -1 is an additional operator. Left and right subtree. Okay. Subtraction operator subtracting the right right and left subtree. We can assume that the tree will always be a valid expression. This is kind of easy because at the leaf node you always return back the value, and if it's not a leaf node, you can simply just go ahead and say, just you know, do the operation. That's all. Do the operation. So it's gonna be a very simple problem. Let's quickly. Oh my god. Yeah. So let's do that. So this is, I cannot copy paste it, but it's -1, -2, -3, -1, -2, -3. Then you have -4, 2, 8, 3, -4, 2, 8, 3, 2, 3. Anything else? No. Okay. So how we do this is very simple. Again, when we reach the leaf node, we return the value as it is. If you're at a non-terminal node, so we take a look at what the value is and just run a switch case statement over it, saying, okay, this is this. That's pretty much it. Okay, that's pretty much it. So this here is -4. -4 is multiplication operator, so this would be 6, and we would be returning 6 in here, and this here would be returning 2. -2 is subtraction, I think. Subtraction. So 6 minus 2 is 4, and this returns 4, and this here returns this. -3 is a division operator. It should be rounded to 0, so it's an integer division. So 8 divided by, so this returns 3, this returns 8, divided is 2. It's 2. It goes back here, 6. That should be the answer, and we're gonna do it in that way. It should be pretty simple in this way. So yeah, let's try and complete it, and then we're gonna take a break. Good. I'm gonna have a smoke. I'm sorry, I don't smoke. I have a smoke. I'm gonna have some tea. Eve. Finally. Okay. So we don't need a separate function for it. It can be done in this particular function itself. If tree is null, we can simply say return 0. And if tree dot left is this, and tree dot right is null, we can just say tree dot value, right, and just return that. Right. So now we have a bunch of switch case in here, which is the operand. So int operand is tree dot value. Okay. So now what we do here is that int LHS is evaluate, and this is RHS. Right. So then we can do a switch on the operand. Well, we can simply operator, not operand, sorry. We got value and not have a find. It's not costly, it's on the stack, but yeah, whatever. So you have a switch in here, and you can say case -1 is just gonna say LHS plus RHS. Okay, and 2 is minus, 3 is divide, and 4 is multiplication. Add, subtract, division, multiplication. And then you have to say a default. So here you can say invalid invalid expression. Okay. This is what it is. It's a switch expression, not a statement. So you can do this. Yeah. So that is pretty much how you do that, and that should be it. If only it supports expression, otherwise we have to change that to a switch case, but that's fine. It says 4. This is not the correct answer. Why? Because this is right, not left. That is right. Copy paste it, but we never fix things. Okay. So there are two things here. One of them, we don't evaluate that, okay, it's the correct data, so we don't do an input validation. And the second thing is in division, we don't do a check that RHS is the same. We can add that if RHS is 0. So arithmetic. And for now, I'm just gonna say it's our number, and this has to be each, by the way. Yeah. This is how you do a switch case expression. I don't know since when it came. Java switch case expression since. Oh, it was actually it was there in the preview. In SE14 it came in. Okay, SE14 came in. Anyone in the chat who works with Java, and what's the Java version that you're working with right now? Okay, cool. So now I can just go and run all the tests. Run. Hopefully it works. All passes. This thing is this. Is there an easy problem later on? Invert a binary tree. This also is a very simple problem. This is the classical meme problem, actually, inverting a binary tree. Have you seen? Not having to invert binary tree. Yeah. That's not the meme that I'm looking for. Well, not the same. I'm talking about the meme where it says 20 days gone. I didn't have to invert a binary tree. That thing. But anyways, okay. Okay, so as we mentioned, we have done 3 problems, and we have done 3 problems. We have done 3 problems, and after we did 3 problems, we're gonna take a quick break, and yeah, I'm just gonna be back in 5 minutes. Okay, sure. So stay around. If anyone is working with Java in production, if you're watching me live and you're working with Java in production, or you work with Java, let me know in the chat which is the version that you're using. Right? Yeah. I'm gonna switch scenes here to enjoy the music. I'm gonna be back in 5 minutes.
just wanna lay down and feel your body close to mine. All I wanna hear you say is that we're never gonna leave this place. But if we ever fade away, I hope you know I'm feeling so high when we're together. Yeah, let's make it last forever. We'll stay young, stay young. We are the perfect lovers. Don't care about the others. I wanna stay young, stay young with you. I wanna stay young, I wanna stay young with you. Hey now, we are young and wild and free. I just wanna shake hands. All the love inside of me, underneath the golden sky. We sit and watch the evening tide. I see the fire in your eyes, and I gotta say, I'm feeling so high when we're together. Yeah, let's make it last forever. We'll stay young, stay young. We are the perfect lovers. Don't care about the others. I wanna stay young, stay young with you. I wanna stay young, I'm feeling so high when we're together. Yeah, let's make it last forever. I wanna stay young, stay young with you.
You're a rebel, getting into trouble. You are kinda like a fire, like a fire, like a fire. Unpredictable, so original. You are never backing down, backing down, backing down. That's what I like about you. So dangerous, I get this rush when I'm with you. I go all in to lose or win. Build things up to knock 'em down. It's the way we keep our high, moving like a hurricane. There will come a time for when we can wash away your sins, settle down, but until then, we're like a hurricane. You're so different, kind of ignorant. You don't care what people say, people say, people say. I'm going crazy for you, baby. Don't know how you're making me feel this way. What can I say? That's what I like about you. So dangerous, I get this rush when I'm with you. I go all in to lose or win. Build things up to knock 'em down. It's the way we keep our high, moving like a hurricane.
Okay, we are back. And okay, since we are back, let's look at the poll result. And two people have voted only. Which JDK used for work or personal projects is Java 8. Yes, that's what it is. Like most people have been working with Java 8 since very long and they don't upgrade. But yeah, there are a lot of new features with Java 25, specifically a performance improvement, script like things. But even if you go to 17 or something like that, it has got a good amount of features. Okay, so maybe if you're not looking at it, you should. Yeah. Okay. Well, I'll keep the poll up and see how many people do vote. Uh, yeah. Let's continue. Let's continue. So the next problem here, or it doesn't even work. Okay. So the next problem here is invert a binary tree. So this is a very, very simple problem. And this one is a hello, Shrikant Rao. Hello, welcome to the stream, Shrikant. How are you doing today? Hope you're doing good. Cheers. Well, camera is here. Sorry, cheers. I still have to get used to this dual setup. I usually don't prefer dual setup, but I didn't like it where I had to keep on switching tab to look at my chat and my OBS, and it comes up on the screen. Um, so it's gonna take a little while to get used to the dual setup, but yeah. Just found your channel on my feed. Oh my god, YouTube, Google, you are recommending me? My god. Thank you so much. Thank you so much for dropping by. So what we do here is that there are two reasons why I started streaming. The very first streams, if you see, I don't know, 3-4 months back, I probably started streaming. Is that one thing is the main motivation is after a year, after 2 years, I want to look at myself. After 5 years, I want to look at myself and I want to see that if I am better, if I have grown. It's kind of a documentation of my coding journey, right? Second thing is, I hope so that it actually helps people get motivated to do recreational programming more and more. The idea is not mine to do recreational programming. It's even though I do algorithms, it's not because I have to sit for an interview, I have to sit for something like that. It's just I love and enjoy. So as you can see, there is no something that okay, I keep on doing algorithms, I keep on doing this. Every day I do a something different stream. Usually, if I'm doing a lead code, neat code, or algo expert, it's because I was lazy and I started my stream late, so I couldn't plan enough. So I will just do this. Uh, Not much of mehnat, I would say. That's one thing. But generally, it's more about exploring different algorithms. It's more about learning different programming skills. It's about building something new. It may be a CLI tool, it may be a system thing, it may be a full stack app. Yeah, just documenting my coding journey overall. So yeah, thank you for dropping by, and hopefully it actually motivates someone to also get into recreational programming. Yeah, look at my cat. I don't know if you can see him. Probably. Can you? Okay. Can you see my cat? I don't think so. Anyways, he is trying to jump around because we found a. Huh? Okay. Um, Say hello to the chat. Say hello to the chat. Hello. हाँ इधर गया पकड़ सकता है उसमें ऊपर पकड़ सकता है yeah got distracted One favor. I'm a second year engineering student. I don't know what are graphs and I want to know about that concept. So if you can explain tree concept to me. You want me to explain tree concept right now? Okay, I'll do that. And look at that, how much you just shedded on me. Oh my god. Okay, I can do that right now, but I will be grateful. No man, it's nothing to be grateful. It's yeah, it's good to help people because in the way you're helping yourself. So one of the things I would say is I'm pretty sure you would already know Navdeep's channel, which is NeetCode.io, I think. Yeah. So NeetCode.io is something I would say you can follow. That's one thing. Why can't you just can I not type anymore? So there are two. I don't know what's the difference, but yeah. This is one thing. This is the second thing. But in general, I would say this guy is the god of programming. William Faisett. If I'm not wrong, he's also a staff software engineer. Google? Do I have LinkedIn? I don't think so. I have a connection of his. I don't remember. Oh, I have sent it, but spending, I'm pretty sure he's never looked at it, but he's a staff. It says full stack, but I thought he's a staff software engineer. Anyways, he's a pretty smart ass guy. And yeah, but coming back to the thing that, okay, and these channels would actually help you learn about trees. But okay, today my Xcali is not working. Like if I put something up, it's a delay. So something is off with my Firefox. But anyways, I will try to use Figma to actually do this, okay? So tree is basically the concept. It's a usually, let's go in this way. Okay, so let's digress a little bit. Are you still there, by the way? Are you still there? Only then I'll start off. Rishikant, are you still there? I'm asking you. If you're still there, only then I'll start off explaining. Oh, okay, cool. So I don't know how much of like software engineering you are into, whether you have a software engineering background or not. But I'm gonna go through some. Okay, so let's first ask that: are you a CS major? Do you know how a computer works and things like that? I'm assuming you would know because you came and straight asked for tree. So I'm assuming you would know something about arrays, something about linked list, and etc. Right? Cool. Okay. So we can talk about that. So usually you have a bunch of memory. Let's just consider this is your memory. So in a pen and paper, we usually show it like this, right? So this is address 0, 1, 2, 3, 4, 5. This is your entire memory of six spaces. Okay. The second thing is that you can create an array. So you can say in whatever programming language you do, it doesn't really matter. You can say I need an array of size 6. Since you're in college, I'm guessing you would do C, C++ or Java. So I'm pretty sure this particular syntax should be like you should be aware of it, right? So if you say an array, it's basically a contiguous memory location. Well, 6 is the wrong answer here. So let's say you want an array of 2, right? So what the computer would do is it would say, take these two things. I'm giving you these two spaces. That's it. And this is a sequential or linear data structure. So what I can do is I can easily say that this is an index of 0. So for some reason in computer science, it always starts with 0, not with 1. So this is the index 0. This is the index 1. Let's say you had a bigger array. So this is the index 2. This is the index 3. And if I have to access, let's say index 2, what it can say is it has a way to keep in memory that variable that you assigned is associated with this particular memory space, right? And it would say, oh, I need to go for 2. So it would come here and it would jump by 2 and it would know this is the element that you're trying to access, right? This is how generally your linked list and your this thing works, arrays work. Linked list works in a different way because you have pointers and all that, but generally for arrays it's a contiguous memory block. And for linked list also, you can think of linked list as either an abstraction on top of an array, or you still kind of create an array but it's randomly, you know, in a memory. So maybe the first element is here, the second element is here, the third element is here, the fourth element is here, right? You just have to keep a track of what is next, right? So similar concept is a tree. So why do you need a tree, right? Why do you need a tree? First of all, tree generally, let's draw a tree. I'm pretty sure you would have seen this, right? So there is a node, there is a left child, there's a right child, there's a child to that, there's a child to this, right? So this is what a tree is. Well, first thing is, array, I can say that, you know, give me a list of Twitter feed. That's an array, right? It's a natural use case. You can say, give me a list of users who have logged into my system. It's a list of users. It's an array of users. It's a linked list of users. So where the heck does a tree come into the picture in a real life scenario, right? That's the first question I think you should ask. Well, let's look at my terminal. So this is the directory that I'm in right now. Dev, GitHub, Priyak, interview prep. You can just say pwd. I'm on Linux, so you can do pwd, which says present working directory. It gave you the entire directory, right? So let's keep this. Okay, this is the directory. If I go one step back and I list all the directories here, not that way. If I list all the directories here, right? Let's say if I go to btrt, what is the path? The path is this. You see, till here, the path is the same, right? The very end, the path is different. So if you extrapolate on this theory, I'm not going to do it for all of them, but if you extrapolate here, right? So there is a directory called home. Then there will be a directory called home Priyak. Then there is something like home Priyak dev. Now this thing will not just have dev, it will have a bunch of other directories, right? So let's say 1, 2, 3, 4. I'm just giving commas so to make you understand. Then if you go inside one, as an example dev, so let's also add dev here, right? If you go inside dev, it would have btrt and a bunch of other folders that you saw, 1, 2, 3, 4, 5, whatever, right? So this right here is a hierarchical structure, because let's say I take this and I put it here. Okay. Let's just read from here. So this is home. Why not I say this is home? Okay. So home can have a Priyak as a child, but it can also have some other things. So let's say A, B, C, whatever, right? It can be a file, it can be a directory, it can be something. Then inside home Priyak, there is a dev. But there are other folders also. There can be, there might be, but in my case, there is none. So let's keep it like in that way. Under Priyak, there is GitHub. Under dev, there is GitHub. And after that, you again have apparently Priyak there. I mean, let's skip this particular part. But here is the interesting part. You have btrt, you have 1, you have 2, right? So as I saw here, there are so many folders that you have in here, right? So this can be btrt, this can be interview preparation, this can be foo, this can be bar, there can be a file saying notes, right? So this is where the hierarchy came into the picture. Because if I start storing all the paths, it's going to be memory heavy. And usually speaking, this is a natural hierarchical structure, right? You have a root, it goes down, and you have a bunch of children in there. So home is a directory, which you can call a parent, which is generally the root where you start your iteration. Okay, so root in a Linux system is the root directory, just slash, right? So if you just go here dot slash, this is the root, right? So if you say pwd, it's just slash, nothing else. But in in here you will have a bunch of folders, right? So this is where one of the folders is home. As you can see here, this is home, right? So if you go inside home, you have Priyak Day, you can have a bunch of folders, but you have only Priyak Day. So things like that, right? So this is a natural hierarchical system. So this is generally a tree. Consider your office, consider you don't work, you're in college. So consider your college, right? You have a principal, I'm supposing. I don't remember how it works in a college, but yeah, let's just assume that this is how it works. You have a principal who would be having a vice president under him or a vice principal under him, right? A vice principal might have all the HODs under him, right? So electrical, ECE, then mechanical, right? So all the HODs are under this VP. The VP is under the principal. Under HODs, there will be professors. Let's say Professor 1, Professor 2, Professor 3. Under professors, usually I don't know if it happens in India, at least in my college it was not there. But anyways, I think I'm from a tier 2 or tier 3 college. I don't know if it happens in IIT or not, or like, yeah, whatever. So you can have something called assistant professors. So let's say you have 2 assistant professors, right? And then under them, you can say there are students or there are classes. It's probably better to say classes or batches, right? So this also is a general hierarchy. This is in general, I'm sorry, this is a general hierarchy system. And this makes more sense that you can represent them as a tree. Does it make sense that why do you need a tree? In real life, why do you need a tree? We could have done everything with an array, but why do you need a tree? Does this make sense? Okay, cool. So we have closed one part, like at least I hopefully made you understand one part of how a tree can be useful in real life. Representing data in computer in the way it is there in real life is very important, because then you can do a lot of access patterns, you can do a lot of read-write patterns, right? So as an example, if you want to say that who all are the professors under HOD, you can simply go to this HOD and ask him, hey, who are all the professors? Instead of, if you go to the professors and if you ask them who is your HOD, and you make a list that Professor 1 is HOD 1, Professor 2 is HOD 1, Professor 3 is HOD 2, and then you figure out who are all the professors under HOD 1. I don't have to do that. I can go to HOD 1 and I can ask him who are the professors under. So these are reportings or children to HOD 1. So it becomes easier that if I have an access to HOD 1, I can quickly access their children. Children is more of a computer science term. Not your HOD's children are professors. I hope not, right? That would be nepotism, because your HOD's children wouldn't be in the professor level yet. But anyways, stupid jokes aside. Now, your memory is still a linear block. Your memory is still a linear block. Your memory is not a tree, right? So how do you do it? Well, usually what you do is what you do for linked list. You have pointers saying this is a node, let's say root, which is stored in this memory block. There's a left child called child 1. There's a right child called child 2. This reference is stored here. This reference is stored here. And your computer will always have access to this. Your program will always have access to this. And what you can say is, I want to go to the leftmost child, right? There, let's say there is something here. Let's say there's something here, right? So similarly, you'll have patterns, like you'll have references. You have access to the root. You can say, okay, I need to go root. I need to go left. I need to go left. I need to go left. Like this, you can access your leftmost children. This is how you generally do it, right? So this is what a tree is stored in memory, right? So if I look at this again, I don't know which programming language you are using, but let's talk about C. I hope they are teaching you C in school, I think, right? So I think how you do that is, which I forgot, but I think how you do that is type def struct. Let's say, so as an example, let's say this is your HOD, right? So an HOD is an employee, HOD is an employee, principal is an employee, your professors are employed, right? So let's say we call it employee, right? So here we say name. Well, not that. So you don't have a string, so it's called name. Okay. So let's say they have a name, right? They can, well, you don't do like that in C, right? No, you do like that in C, right? I forgot, my bad, sorry. We're not doing variables, but anyways. So now you might have an age, which is an int 32. Right, you can say int. Now, the important part is you have a list of professors who are, let's just keep it simple here. So let's call it HOD. Okay. So you have a list of professors who are reporting to the HODs, right? How do you store them? So let's have another struct called professor. They also have the name and age. Since they have the same thing, I was trying to do the same struct, but it might get more confusing. So let's just say they have this, right? So in here, what you do is you can have a list. Professor. You can have a list. I don't remember if you do that in C, but I think you can just say professor. But that's not the main point. C syntax is not the main point. So it has a list. So it is always not left and right. It can have n number of children also, right? So this is what a tree is. And generally how you solve any kind of a tree problem is recursion, because if you're trying to look for an answer, it is most likely that your children will have the answer, which you can return back to the parent. The parent will use the answer it got from the children and try to do something about it and return back to its parent, right? And return back to its parent and things like that. Let's look at a problem. Till now, have I been able to successfully make you understand a little bit? Till now, did you understand that how a tree works in real life, and this is how it's stored in memory? This is how generally you do in a programming language. Again, I put it in C, but it really doesn't matter which language you're doing it. Whatever language you're doing it would have some sort of construct to represent this kind of a structure. Okay, cool, awesome. Next thing is, let's look at a problem. So I think this particular problem was simple. It's saying evaluate expression tree. So expression is, okay, that may be, yeah, I mean, why not? What is an expression? 1 plus 2 is an expression, 2 plus 3 is an expression, 1 plus 2 into 3 is an expression, right? It's a mathematical expression, right? We have done maths in school, so we are just trying to say that this is an equation. 1 plus 2 minus 3 into 5 into 8, right? So this is a mathematical expression, and we as a human can say, oh, we have to go left to right because of BODMAS rule. We have to go left to right, but this takes preference, multiplication. So this will be 24. After that, left to right I have to do. So 1 plus 2 is 3, minus 24, minus 21. So this has to be minus 21 is answer. But how does a computer know that first it needs to evaluate a multiplication? Sorry, first it needs to evaluate a multiplication, then it needs to do a plus and minus, but plus and minus can be done from left to right. How do you know that, right? So there is something called prefix, postfix, I think infix and all of that. Even I don't remember all those things, honestly. But generally a postfix one, I think, is how you can do order precedence and all of that, right? But coming to the main point of, this is a similar kind of problem, okay? This is a similar kind of problem. So generally you create a tree. Generally, to evaluate any expression, you create a tree, right? Because think of it like this way. Let's go back to the diagram. 1 plus 2, right? So maths term, LHS, RHS, you have to add them. That's basically it. Sorry. And then there was a minus 8, right? So what happens is that minus 8 comes second, So you can say this is 8 and this operation is a minus. So this is how you can represent. So this is called a leaf node. How you have a general tree that leaves are the end of the branches. So this is called a branch, just a normal reference. This is called a leaf because it is the end of it. You don't have anything, any children after that. And this is called the root. This is called the root because it starts everything, right? So think of a normal tree in your real life, which is inverted. Like you somehow planted the leaves inside and then it grew up. It grew up, okay? Think in that way. Okay, think in that. But yeah, that's why it got the name tree, because that is what the hierarchical structure is. Okay, so the question here is very simple, saying that you don't have to generate this thing. So they are not giving me this and asking me to generate the tree. They're giving me the tree and they're asking me to evaluate the answer. Okay, so how do we do that? So let's look at the question first, I think. Evaluate, yeah, that's the one. Okay. Okay. So what they're saying, you're given a binary expression tree. A binary, the term binary in English means 2. So generally for computer science, you say binary means 0 and 1. But in general, a binary thing can be 2 things, right? So binary values can mean 1 and 2. Binary data is generally 0 and 1. That is what my brain also comes to think as of now. But if you talk to a person who's not a computer science engineer, it's basically 2 things, right? Binary. So now in here, what they're saying is it's a binary expression tree. Now, what does a binary tree mean? A binary tree means that every root, every node, usually we call it a node, every node will have a maximum of 2 children. Like I said, that a professor can have multiple assistant professors under him, which means n number of children it can have. But in here, there's a constraint saying every professor will only have 2 assistant professors, maximum of 2 assistant professors. Okay, it can have 0, it can have 1, or it can have 3. So this is a binary tree. So yeah, coming to the point that, okay, how do you do, not this, coming to the point, how do you do this? Evaluate the expression tree. So what it says is that, hey, the leaf nodes, which means the end nodes, will always have a positive integer. Well, positive integer or negative integer really doesn't matter. And all the other nodes are, operators. So I did the same kind of diagram here, right? These are actual values, like mathematical values, and these are operations that you can do, plus, minus, blah, 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 right? So you have to evaluate that, right? So, and every kind of operator means different. So -1 means it's a plus thing, -2 means a subtraction and all that, blah, 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 whatever, right? So if you look at the tree that they have given in here, root is a non-leaf, so it's -1. This is a non-leaf, so it's a -2. This is a non-leaf, it's a -3. So these are operations. Here, I have just replaced it with the actual signature. I could have generally just said -1, -2 here also, right? So how do I solve this problem? Well, if you look at this problem, right, generally what you can do is, if you go to the leaf node, what is the data that you're expecting from it? The data that you're expecting from it is the value itself, right? Because let's say I said 1 plus 2, and this was the binary tree, right? Recursion is a concept of calling the same function from itself, right? So you called the same function, you asked it to do the same kind of operation for the left child and the right child. The left child and the right child are nothing but integer values. So can I do anything 1 plus 2, 2 plus 3? No, right? I can simply say, hey, this is my value. You take it and you do whatever you want to do. This is my value 2. You take it and you do whatever you want to do, right? So if you look at my code, I have a condition in here where it says tree.left and tree.right is null. It means that both the references are null, so both the children are not present. So it's a leaf node. I'm just going to return the value to whoever is calling me. Someone would be calling me, right? Someone is calling the function. So you go back to that guy. This is the value. You do whatever the fuck you want with that. Now, if you would have passed the actual root, it would have, you know, one by one gone down recursion, because you see this is what recursion is. I hope you know what recursion is, but you can look it up. You're calling the same function over and over again from within, which also means you can infinitely do that. So that is why these are called base conditions and things like that, right? Otherwise it would be a infinite loop technically. And here you call for the left, you call for the right, and you get the answer at some point, right? So here it would have returned 1, it would have returned 2, and at this point for this particular tree, this is where you got LHS as 1, because LHS is coming from the left and RHS from the right. And I just do a switch case. If you're not familiar with, I think you're familiar with this, I'm not sure, but yeah, again, this is just programming familiarity of switch case. I am saying that this is case -1, which means a plus, so I'm just going to add these two, right? So I'm just going to say this was plus, so I'm going to say 1 plus 2. All right. Then there might have been another parent here, right? So this also returned 8, and this returned back 3, and this is now minus. So in the next function call, well, in the like unrolling of the function call, as the stack unfolds itself, it would say, oh, 3, you got 8, and I have to do a minus to this, so the answer will be -5. So this is how generally you tackle any kind of tree problem. You try to figure out that on a larger scale, what kind of answer I want to get, and what kind of answer each node has to return me. What kind of answer it has to return me, so that the parent, what kind of answer the children needs to return to me, so that the parent can do something with it and return it back to its parent. This is what a general mental model of approaching any kind of problem is. Okay. That's what I can say right now. Again, yeah, I hope I made things a little clear, but I use a lot of terms. One of the things I would say is program is tree data structure. I think this is a good thing. You understand what a tree data structure is. You then go through a tree traversal. There are different ways to do tree traversal, so you can learn it from here. Terminologies. So what is a node? What is the edge? Edge is nothing but this line connecting. The reference, right? the pointer. What's a root? What's a height? And things like that. So these are all terminologies that you think you should know. So I feel this is a good starting point to learn about trees. I already shared for William Fawcett, but depending on your skill set right now, because he's quite advanced, but I think he does start from basics. Not sure, you can check out. Yeah, so balanced tree, binary search tree is till here, I think you should be very familiar till you are in the final year. AVL tree, though I've been working for 10 years, I have not used it, and I cannot code it also, and I don't know also what how it actually does balancing and all that. So it's kind of very advanced concept. Then there is tree based, like tree based 2. These are more advanced trees. So there are different kinds of trees, right? So as an example, I don't know if you have plants in your home, but you generally should have seen tree outside. So there are so many varieties of tree, right? You have a mango tree, you have a guava tree, you have this, you have that, right? Same thing here also. You have a bunch of different things. The main reason people came up with different things is they're trying to solve a certain problem, and they came across that, okay, the existing concepts are not, the existing trees are not supporting the operations that I want to do on the data set. So is there a different way that I can generate the tree so that, so some of the trees may be easy for searching, some of the trees may be built for more data compaction, like maybe you have a large data set, you have 1 billion rows, but can I, you have a 1 GB file. Can I make it compact and store it on the actual hard disk in small? Because if you start storing 1 GB file as 1 GB, it becomes kind of tedious, right? It becomes kind of costly. So computer science came up with a solution saying, okay, I'm gonna minimize the file in a way that 1 GB can be stored in, let's say, 700 MB. So I'm saving 300 MB. But when the user wants to see the file, I have not lost the data. That 300 MB can be created back from the tree that I generated. So different use cases, right? Different use cases. Another thing, I don't know if you know about recursion, but recursion also, I think you would know, but I don't know if they. Yeah, let's do Geek for Geeks. I mean, again, these are some things that you can Google, man. But yeah, I hope I made things a little clear. I don't know how clear over chat, but yeah, I think I made things a little bit more clear. And now you can go ahead and explore more. That I think this program is really good. Had one doubt on my college project. Can you explain what is a directory stir? Directory stir. I have no idea what that is. What? Structures of directory. I just mentioned. Okay. I don't know if this is what you wait. In Python's OS model, when referring to a directory string, it typically means a string representing it's just the name of the file system we're talking about. I'm not sure what that is. Directory stir. One, I'm not a computer science engineer. I didn't do a CS degree, so I never had formal operating system subject course. I still haven't yet touched any books for operating systems. All my knowledge is just over the years of playing around with things. And what is a directory in an operating system and what is a directory structure? I already showed you. This is exactly what you're talking about. And one of the things that tree is useful for is generating a directory structure. So I don't know, maybe in colleges they teach you how to create your own OS. That would be so fucking cool, but I don't know if they do it. But if they do it, if you're creating your own OS, you have to build a directory structure. So this is how you would build a directory structure, saying this is a top level root, and then there's a tree, and how can you traverse it? Because when I say cd into dev github react.day and then what it needs to know that it has to go there. So how do you traverse from home? I was at home, I said cd this thing, it quickly, within a millisecond, we can see how much time it takes. With not even like milliseconds, right? It immediately went there. So how do you store this information in a hierarchical structure so that it's quick to access and things like that? So I'm guessing that is what directory str is. Or I'm guessing str is for structure, but I already told you this is a directory structure, so I guess I already answered that. Yeah, cool. I hope I helped a little bit. Cool. Okay, so we are already. Thank you for sharing your knowledge. Help me a lot. Welcome. As in when I talk and as in when I say, I feel I'm also learning and revisiting things, and it makes me think also that if I'm saying something right or wrong, and I just call it out that hey, I'm wrong, I'm sorry. People can be wrong, it's okay. I know some people would get very angry if you call them out saying something you said is wrong. It's pretty dumb, they're pretty dumb. But yeah, if I said something wrong on stream, I would say, or on any videos or something, I would say, hey, oh my bad, that is wrong. What I'm saying, it feels wrong. But yeah, explaining also, it feels good. One of the main reasons again I wanted to stream is that, like, because I talk and I do things, like the moment I say something, it comes to my brain, it feels like it, and then you can immediately evaluate what you said. Does it make sense or it's just dumb shit? It immediately makes sense. Even for if I'm trying to solve an invert binary tree and I start talking about, oh, this is how I'm going to solve, this is how I'm going to solve, the moment I start talking out loud, that is when immediately I can catch in my head, oh, what I said is something wrong, so this is not going to work out. So I think talking out loud of any problem statements and all that is very important. Yeah. Okay. Lots of talk. We didn't do anything for the last 1 hour, I suppose. Yeah, bye. Thank you for stopping by. Bye-bye. But let's quickly try to... So we solved 3 problems today. Let's try to see how many problems we can solve before we are hungry. Okay, invert binary tree. So I'm not going to go into diagrams and all that because I'm just practicing, let's say. So yeah, if anyone has any questions how I'm solving it, I can then go to it. Otherwise, I'm just going to, code it up. Invert binary tree. Write a function that takes in a binary tree and inverts it. In other words, functions swap every year. So this is again very simple. You take left and right and you just swap it around. This is a very, very straightforward problem. So we can ignore the white. So how do you do it? This right here is very bullshit. It doesn't return back anything, which means I cannot use its function. So I have to create something like this, and since it's not overloaded, I have to say something like this and node. Okay, so if node left is equal to null, and node dot write is equal to null, you can return the node itself. But of course, I have to say binary. Okay. Otherwise, node dot left is right. So whatever answer I'm gonna get from the right is gonna become my current right, and whatever answer I'm gonna get from left is gonna become my mistake, right? And then I'm gonna return the node. So, well, we don't have to reassign 3 because 3 is it's just a reference and a single node, so it's gonna be fine. Okay, so this is the problem. This is the problem solution. But there are 2 problems to the solution. Anyone knows what the problem is to the solution? What is wrong with the solution? पापा अब से फैमिली ग्रुप में वॉइस कॉल ज्वाइन करके बैठे हैं शाम से, पता नहीं कैसे, but he is joined and he is there since evening. Huh? And it's okay now. Anyways, there are 2 problems to it. The first one here is that we don't have a null check. So we do recursion, but if it's null, then this thing is gonna fail because null dot left. So it's gonna be a null pointer. So if node is null, we can return null, and we can kind of put together these things. So this is one thing. This is the first problem. The second the second problem is here we are passing node dot left in the second line, but in the first line we have already assigned node dot left, so that's gonna mess up everything. So binary tree left child, binary tree right child. After we do this, node dot left will be the right child, and node dot right will be the left child. So we have to assign after we are done that. It's saying that okay, it's not, you can inline it, yeah, but I don't want to inline it. I don't want to inline it. Then you can return it. So this here should be the solution. Oh, I see a lot of people actually voted. 5 votes, and only 1 vote is for JDK 17. Everybody else is using JDK 8 in their projects. That's pretty. Wait a second. What just happened? What just happened? Yeah?
You're a rebel, getting into trouble. You are kinda like a fire, like a fire, like a fire. Unpredictable, so original. You will never
Are you asking me to reassign it back?
backing down. That's what I like about you.
Is that what you're expecting from me? Because the code is absolutely correct. No. If I reassign it back, it messes up everything else. What the fuck?
It's the way we keep our high, moving like a hurricane. There will come a time for when we can wash away your sins, settle down, but until then, we're like a hurricane.
What? It's still 2 and 3, but you're expecting 3 and 2. You're calling this function, calling it with the root, and then you're calling this function, you're calling it with the root. Then you're saying, okay, if you have reached this terminal conditions, simply return a node. Nothing else to be done there. So the left child is you're calling with the right. Aha! My bad. Yeah. My bad, sorry. Because now we are first binding and then reassigning. Binary tree diameter. And returns the diameter. The diameter of the binary tree is defined as the length of its longest path, even if the path doesn't pass through the root of the tree. A path is a collection where no node. Okay. But I think, yeah, we're at 11 o'clock right now, and I think I'm gonna stop the stream. We're streaming for almost 2 hours now, I think. Yeah, we're streaming for almost 2 hours. We had a 5-10 minutes break, and I'm hungry now, so I'm gonna stop the stream. Tonight I will not come online again because tomorrow I have office in the morning. So, and I want to play some games in the honestly. So what I'm gonna do is I'm gonna stop the stream. Thank you everybody for who joined in, and yeah, thank you everyone for who joined. Thank you so much. I hope you enjoy the stream. I'm gonna quickly come up with an idea of what kind of content I want to make. Like, what I mean by that is I don't want to keep on doing algorithms and DSA problems like this. So I'll come up with something. Well, we can finish off the to-do application. We can finish off with the 99 TypeScript problems. I think that's another interesting thing, or something else. Okay. So maybe I'll put up a poll on the community post that what people want to see, and depending on the votes, I'm gonna start streaming that particular sequence. But yeah, let's see. Sometimes I also just stream what I want to do and what I want to learn, like what's the mood that day. That's also there. Yeah, so sorry if somebody votes and I just stream something else. So yeah, but yeah, we did a poll tonight and we were asking a question that which JDK you use in your work or personal projects. And I mean, it's already understandable that majority of the people have voted for JDK 8. Like I said, I'm still using some of the features of JDK 21 and things like that. I'm using 25 on my local. If you're working with Java or any programming language, my suggestion always is to look into what's new and what's coming. Because at times it might be possible that you cannot upgrade the newest thing on your project. But if you're aware of what's going on in the industry, if you're aware of what is going on in the new thing, if you're in a position, you can go to your manager and always say that, hey, you know what, if we upgrade, these are the better things that we get. If you're in a position to make that call, of course. Or you can just show a POC to your manager saying, like, you know, like if you upgrade, these are some of the benefits that we can get. Maybe clean code, maybe performance, maybe blah, blah, whatever. So yeah, I feel you should be updated with it. I'm pretty sure people are, but just I'm saying, but it's quite relevant and understandable that the industry is still, you know, conforming to what is battle tested, and you know, we don't want to upgrade and break something and get some more work done. But yeah, okay. Thank you so much for joining. It was a good session. We had some good problem solving. Tomorrow, maybe I continue on this, maybe I don't, but I quickly want to move towards the more harder and like medium level and harder and these kind of problems. My light just switched out, but I hope that it's not too dark. But yeah. So yeah, thank you so much and have a good day. Have a good night. Thank you. Bye-bye.